All right, welcome back, geometry. So this is part 2 of the lesson. So in the first part, we learned how to use the segment addition postulate to solve problems, as well as set up equations in order to solve for an unknown. Okay. In this lesson, we're just going to touch briefly now on what can we do with a number line. Okay, because remember that one of the things that we learned when we unpacked that embedded assessment 2 is that we really need to learn how to use a number line in order to find distance and midpoint. Okay, so the first question here is, given this number line with this segment on it, LM, what is LM? Notice no line above it, which means that what this is really asking is what is the length of LM? What is the distance between points L and M? Okay, so a couple different ways we could do that. We could just count, right? So 1, 2, 3, 4, 5, 6, 7 units long. Okay, notice the way I counted. I didn't count 1, 2, 3, 4, 5, 6, 7, 8. That would be incorrect because if I count this as 1, that means I'm saying that if I put a point right on top of this point, it would be 1 unit away. Okay? That doesn't make sense. That should hurt your brain a little bit. Okay, so instead, make sure you count 0 and then 1, 2, 3, 4, 5, 6, 7. Okay? Another way we could do it is we could also subtract the numbers. So we could say, 4 minus -3, and of course minusing a negative becomes a plus, which would be 7 as well. Okay. So either way, however you did it, if you counted it or if you subtracted, you should have come out with 7 units as the length of LM. Okay. Now what if we wanted a midpoint? Well, I think that would be quite doable as well. Okay, so I have this segment here, PQ. Notice the number line here, okay? This is counting by 4s. You would have to keep that in mind if you were finding the distance of PQ. Which, speaking of which, let's go ahead and do that. So for the distance from point P to Q, we would need to do 40 minus 8, right? Which means that the distance between P and Q would be 32. Fantastic. Okay. Now, the midpoint is going to be exactly in the middle. Okay. So I could count it in. Okay, I could say, okay, that's in 1, that's in 1, this is in 2, 2, 3. So this is my middle point between them. So that's where M would have to be. Okay, I could also do it with this number, okay, because remember, the midpoint divides the segment into 2 congruent pieces, which means if the whole segment is 32 units long, if I divide by 2, that would give 16. Means that the midpoint must be 16 units away from either of the endpoints because each of the halves are 16 units long. So then I could come here and say, well, if this one's 8, 8 plus 16 is 24, or I could go the other way, 40 minus 16 is also 24. Either way, I end up at this midpoint at 24. Okay. Please note there's a huge difference between distance and these coordinates on the midpoint, or on the number line here. Okay. So, for example, the distance between M and Q is 16, but the coordinate of the midpoint is 24. Okay, so coordinates, that's the number at which they're landing. Distance, that's describing how many units there are between them. So let's go ahead and check our understanding. We're just going to do parts A and B. I'm going to save parts C and D for the Monday in class for us. Okay. So let's use this number line to solve each of these problems. The first thing they ask us is, what is KL? Remember, no line above it, so this is asking for the distance between point K and point L. Okay. So I could count 1, 2, 3, 4, 5, 6, 7, 8, but my distance is not 8 because notice each of these segments here are 3 long. Okay. So you could do 8 times 3. That would give you 24. Or you could do 15 minus -9. That would also give you 24. Whatever way you prefer, this segment is 24 units long. Next thing they want are the coordinates of the midpoint of KL. Okay, so let's see if I can count in. So that's 1 in on both sides. This is 2 in on both sides. This is 3 in on both sides. So this brings us here, right? So I'm going to say the coordinate of the midpoint is 3. Now, if I wanted to do that from the distance, I totally could. I could instead do 24 divided by 2. tells me each of the halves of this segment should be 12 long. So negative 9 plus 12 is 3, or I could do it the other way. 15 minus 12 is also 3, landing me right there. Okay. So the coordinate of the midpoint is 3. Okay. All right, so let's do a quick target check then. Okay, so you should now know how to use the segment addition postulate to solve problems involving lengths of segments. You should also be able to use the definition of midpoint to solve similar problems. We've also touched a little bit on distance and midpoint with a line segment, which I'll ask you to practice a little bit too. Okay, so right now you should have a segment addition postulate practice in front of you. Please complete that. That is due by the end of the hour and needs to be turned into my box. Okay, your notes packet that you just filled out all this lovely information on, please make sure it finds a safe place. I'm not collecting it. I want you to keep your notes, and we'll finish the second part of this lesson, the rest of the packet, on Monday. Okay, so have a fantastic weekend, and I will see you then.